Hello everyone, welcome to another video. Today I want to give you an introduction into how the scheduling of pods works. A couple years ago, when I got started with Kubernetes, I didn't care where my pods will end up. I just told Kubernetes, create some pods and let it take care of. But actually there are quite a lot of options we have to make sure that we can decide where our pods will be scheduled. So the plan for today is, first, I want to talk about Quota. This will allow us to limit the resources our pods use. For example, we can limit the CPU usage, the RAM usage, but we can also limit the amount of pods we have. And afterwards, we're going to take a look how we can configure our pods, where they should be scheduled. So first, we're going to take a look at the node selector, then at Affinity and Anti-Affinity, then Taints and Tolerations, and in the end we're going to look at pod spread, which will help us to spread our pods all over our nodes. This will ensure that not all our pods are running on the same node, and if the node goes down, our application goes down. This is just an introduction. There's so much more, but I think, especially if you're a beginner, it's good to know that these things are out there, and it will get you started so you can look it up yourself if you're interested. As always, you'll find a link in the description to all the demos on GitHub, or you can scan this QR code and then we'll also find the demos. One last thing, I named the video AKS Pod Scheduling because I'm using AKS, but this will work with any Kubernetes cluster. The reason why I named it AKS Pod Scheduling is I'm going to show you a couple of things in the Azure portal. For example, the labels of nodes, because it's just nicer to see there. But again, you can use any Kubernetes distribution you want. It will work there. With that said, now let's switch over to the terminal and let's get started with creating our Kubernetes cluster and then trying out all these different options we have to schedule our pods. Alright, here in the terminal, let's define a couple of variables first. So that's the name of our AKS cluster, name of the resource group and the location. Then we can create the resource group. So we just provide the name of the resource group and the location which we just defined. Once this is created, we can create our AKS cluster. Here we provide again the name of the resource group and the cluster itself. And I create a cluster with 2 nodes. This is useful for the demo later, but you can use any amount of nodes you have. So let's get this started. It will take a couple minutes, and once this is finished, I will come back and then we continue with the demos. Our cluster has been created. Now I can download the credentials, and with this we can access our cluster and get started with the first demo. So the first demo is about the quota. With the quota, we can configure how many resources a namespace can use. This could be a CPU limit, a memory limit, or the amount of pods. This makes sense, especially in a multi-tenant cluster, to restrict namespaces, so one namespace doesn't use all the resources of the cluster and starves all the other namespaces. For all the demos today, I'm going to create a new namespace, so the demos don't interfere with each other. So let's get started with creating the namespace Quota. Then I'm setting the context to the namespace of Quota, so I don't have to type the namespace all the time. And then I'm going to apply our first quota. So I'm going to apply this. And now let's take a look at what this YAML file actually does. Here you can see the YAML file we just applied. It is of type resource quota, and then we define the quota. In this case, we define that the request for the CPU is a maximum of 1. This means 1 CPU core. And the limit of the CPU is a maximum of 3. This means all our pods combined are allowed to have a limit of a maximum of 3 CPU cores and can request 1 CPU core. Now let's go back to the terminal. Here in the terminal, we can also take a look at this quota. So we can do a kubectl get quota. Then we get all the quota of this namespace. And here we can see exactly what we just saw in the YAML file. We have the request for the CPU, a maximum of 1, and currently we're using 0. And the same for the limits of the CPU. We're currently using 0 because we haven't deployed anything, but we have a maximum of 3 there. So now let's deploy our first deployment. Let's apply this, and then we're going to take a look at the file itself again. So this deployment is created, and while the pods are being deployed, let's take a look at this YAML file. Here we can see it's just a very simple deployment. We deploy whoami from traffic. We have 3 replicas. That's something to keep in mind. And a bit further down, we set here the resources. This means we set for the limit a CPU of 500 millicore or 0.5 cores. And for the request, we have 350 millicore. As I said, remember, we want to have 3 replicas. And now let's switch back to terminal and let's see what actually happened. So here in the terminal, let's clean this up and do a kubectl get pods. Here you can see we only have 2 pods running, even though we wanted to have 3. So now we can take a look at the quota again and figure out what's happening. So we do again a kubectl get quota. Here we can see we already use 700 millicores of the 1000 or full CPU core. And if we have the third one, it would request another 350 millicore, and this is over the quota we have defined, and therefore it cannot be scheduled. We can dig even further. Now we can take a look at the replica set. So we do a kubectl get replica set, and we get the name here, and we also see here we have desired 3 and current 2. That's exactly what we've seen with the pods. But technically, when we create a deployment, the deployment creates a replica set, and then the replica set creates the pods. This means the replica set is in charge and also knows what's going on. With this name, we can do a describe of this replica set. So I'm going to copy the name. Then we do a kubectl describe replica set and paste the name we just copied. And here we can see the error message. It's a bit of a wall of text, but you can see here error creating pods. And a bit further here, forbidden, exceeded quota, CPU quota. This means if you don't know what the problem is, you can now take a look at the quota named CPU quota, and you will figure out what the problem actually is. So now we have seen we can set a quota on the CPU. With memory, it works exactly the same. So let's delete our pods and our quota. Just do a kubectl delete deployment with the name. The same for the quota. And now we can also set a quota for the amount of pods we have, or the total number. So I'm going to apply this file. Now let's take a look at this quota pod YAML file. Here you can see we have again the type resource quota. This time we specified the pods and we set it to 1. This means our quota restricts us to use only 1 pod in this namespace. To test this, now let's deploy the same application we had before. So there we wanted to have 3 replicas. This means we should have 3 pods. But thanks to our quota, we will see that we only have 1 pod running right now. Again, we can do a kubectl get quota. There we can also see that we have the limit of 1 pod and we're already using 1 pod. Okay, this wasn't really scheduling. It was more limiting, but I think it's kinda in the same ballpark. But now let's take a look at actually how the scheduling can work. So let's clean this up, and we're going to create a new namespace. Then again, set the context for the namespace. And now let's take a look at the labels of our nodes. I want to take a look at the node selector. This means we can tell our pods on which node they should run. This is very useful if you have a mixed node pool. For example, if you have some Windows and Linux nodes, or you have some nodes with special hardware. Nowadays, everyone wants to do AI. And if I have some AI software, I want to run it on nodes that have, for example, NVIDIA graphics cards. And you can do this with labels. But first, let's take a look at the labels we already have. So you just do a kubectl get node and show the labels. And here you can see we just get a full-on wall of text. It's very hard to figure out what's going on. So let's switch over to the Azure portal, and there you can see it easier. Here in the Azure portal, we have the resource group we created before with our AKS cluster. Inside this AKS cluster, we can scroll down a little bit until we see the node pools. There you can click on the nodes, and here you see 2 nodes. That's exactly what we configured before. If we click on one of the nodes, we also get some information about the nodes. And if we scroll down a bit, we can see here we have a total of 34 labels already. And AKS also uses these labels to figure out what's going on with the nodes. For example, here you can see what operating system they have. In this case, it's a Linux. We can also see the region where we have deployed it. We have availability zones. So there's a lot of information that can be useful. Now we're going to add a new label. For example, we can say that the GPU is NVIDIA. And then we can deploy our pods and tell them, or tell Kubernetes to only schedule them on a node that has a GPU graphics card. To be more specific, to deploy on a node that has the label GPU equals NVIDIA. So now let's switch back to the terminal and let's apply these files. Back in the terminal, let's clean this up. Then let's do a kubectl get nodes. And here you can see the same 2 nodes we have seen before. What's important here to remember is one is called VMSS with a whole bunch of zeros, and the other one has a 1 at the end, so we can distinguish them. Now we do a kubectl label nodes. Then we provide the name of the first node. And then we provide what label we want to set. For example, that the GPU equals NVIDIA. Then we are going to deploy our application. So as before. And while this is being deployed, let's take a look at the application we have just deployed. Here you can see the YAML file, and it's actually just a pod we deployed. But what's important is these last 2 lines. Here we set the node selector to GPU equals NVIDIA. This means this pod is only being scheduled on a node that has the label GPU and the value of NVIDIA. We can test this by describing this pod, and then we'll see it will run on the node with all the zeros. That's the node we labeled with GPU equals NVIDIA. So let's switch back to the terminal and let's see if that's actually true what I'm telling you here. To check where our pod is running, we can do a kubectl describe of the pod and provide the name we have given it. Then we can see all the information, and we can already see here successfully assigned with the VM with all the zeros. But also, if we scroll up, we can see here that it has the node selector of GPU equals NVIDIA. And then if you scroll even further up, there we can see somewhere the node it's running on. So here you can see the node, and again, it's the one with all the zeros. And with placing these labels, you can configure or tell Kubernetes where you want your pods to be running. You have to be a bit careful, because in this case, I have 2 nodes and 1 node is for NVIDIA. So if I schedule all my pods for NVIDIA on this 1 node, and this 1 node goes down, all my applications also go down. So in a real world project, I would have probably 3 nodes with NVIDIA GPU label. And if one of these nodes goes down, it doesn't matter because I still have 2 left. And then Kubernetes will take care of creating the 3rd node again. So let's clean this up. That's everything I want to show you about the node selector. Next, I want to show you affinity and anti-affinity. So with affinity and anti-affinity, you can tell where you want to have your pods running. So you can say, I want an affinity. This is where you want it to be running. And with the anti-affinity, you can say where you don't want it to be running. It may sound a little bit confusing, but let's deploy a demo and then you'll see what I mean. As always, let's create a new namespace and set the context to the new namespace. Then we're going to deploy our demo application and we're going to switch over to Visual Studio Code and take a look at this demo application. Here you can see it's again one pod I'm deploying. And with the affinity and anti-affinity, you can have node affinity, which we have here, but you can also have the same for pods. And as you can see, there's a lot going on. So let's take a look at it line by line. So first we have the affinity and we say it's a node affinity. This means our node has to match this expression. So our pod is deployed on this node. Then we have a soft affinity and a hard affinity. So for the soft affinity, this would be here. It's called preferred during scheduling, ignored during execution. A horrible keyword. And the hard affinity is down here. That's required during scheduling, ignored during execution. The difference between a hard and a soft affinity is if Kubernetes can't fulfill the hard affinity, the scheduling of the pod will fail. This means in this case, we want to have a node with the selector of a label that's the key is GPU and the value is NVIDIA. If no node has this label, then the schedule will fail. On the other side, in the soft affinity, it will still work if it's not available, this label. It's more like a preference with the soft affinity. Additionally, with the soft affinity, you can set a weight. So it goes from 0 to 100. The higher the weight, the more priority it will get. And with this, you can set different priorities. And then Kubernetes will figure out which node fulfills it the most and then schedule it there. So you can configure quite complicated scheduling mechanism. But for now, let's just leave it with this one affinity. So we want the label GPU and the GPU and the value NVIDIA. Then the second one we have is the anti-affinity. Here you can also say node or pod anti-affinity. And this is the opposite of the affinity. So if the expression is true, then we don't want to schedule our pod there. So in this case, we have a label selector for an application. So if one of the pods has the label with the key app and the value nginx, then we don't want to schedule our pod on this node. This can make sense if you have two applications that shouldn't run on the same node. For example, I'm deploying a traffic application right now and I don't want to have nginx running on it already. In a real world project, you probably don't care too much about nginx running, but you care more about applications that use the hardware. For example, if I already have pods that use the GPU fully, I don't want to have another application that also needs the GPU. Another example could be a database. If I have one database running that already needs a lot of resources, I don't want to have a second database running. And with this, you can configure it. Also, the last line here, the topology key, we set it on the host name. This means we care about the nodes. But in AKS, you can also set it on a region or availability zone. And so you can make sure to spread your pods around availability zones. So if one zone goes down, your pod or your application will still be running because it's on another availability zone. All right, so with this, we have here this node affinity with the label GPU and the value NVIDIA. This means, again, our pod should be scheduled on our first node with all the zeros. Let's switch back to the terminal and let's see if this is actually true. So here in the terminal, let's clean this up. let's do a kubectl describe pod with the name we've provided. Then we can already see here it's running on the node with all the zeros. Since we don't have nginx running, the pod Anti-Affinity was always true. So in this case, it wasn't a problem. And only the node affinity played a role in scheduling the pod. The next option I want to show you is Taints and Tolerations. This was to me a bit confusing because of the naming, but the way I remember it is we can give a taint to a node and then we can configure our pods to tolerate these taints. If our pods don't tolerate them, then our pod won't be scheduled. So let's clean up this window. Let's create a new namespace and then also take a look at our nodes again. So we here have the two nodes. And now let's set a taint on each of the nodes. So we do a kubectl taint nodes, then we copy the name. And then we can configure what taint we want to set. So first I'm going to set the taint, the GPU equals NVIDIA, and the result of this taint. In this case, it's no schedule. This means that our pods have to tolerate the taint GPU equals NVIDIA, and if they don't tolerate it, then they won't be scheduled there. We can do the same for the second node, except this time I'm going to set it to AMD. Just to simulate, we have an AMD GPU, and we set the name of the second node. Then we're going to deploy our demo application. And let's switch over to the Visual Studio Code and let's take a look at our YAML file we just deployed. Here you can see the YAML file, as always, very simple, just one pod of who am I. And what's important here are the last couple lines. So here we configure the toleration. We set the key to GPU. And if it's equal to NVIDIA and the effect is no schedule, then we want to deploy our pod there. So it's a bit confusing because the effect is no schedule, but we want to schedule it. But again, the easiest way for me to remember is we tolerate this taint, therefore we can schedule our pod there. So if you go back to the terminal and take a look at our pod, then it should be running on the node where we have the NVIDIA, which is the first one with all the zeros. So let's clean this up. Let's do a kubectl describe pod with the name. And here we can see we have it running on the first node with all the zeros. To prove to you that we can control where it's running and it's not always deployed on the first one, let's delete the pod we just deployed. Then we're going to take a look at our YAML file and change it to AMD. If we now deploy it, then it should run on the second node because the second node has the taint of AMD. So back in the terminal, let's apply this file again. Then we're going to wait 1 or 2 seconds and then we do a kubectl describe again. And here we should see that we have it running on the second node. So in this case, if we have an application that needs a AMD GPU to run, then we can make sure that in this case, we can deploy it there. The last option for scheduling our pods I want to show you today is how we can configure to spread them across all our nodes. By default, Kubernetes already does quite a good job on scheduling our nodes, our pods, but we can also configure that. So here in the Azure portal, scale our node pool to 5 nodes, and then we can test it. As you may see here, I have a new node pool because the old one had 2 really big nodes and I ran out of quota. Now I have smaller VMs and I should be able to scale them to 5. To do this, we can click on Scale Node Pool. Then we can set the number of nodes we want to have, in this case 5. We click on Apply and then it will take a couple minutes and we should have 5 nodes running in our node pool. So once this is finished, I will switch back to the terminal and then we deploy our last demo application for today. So the node pool has been updated to 5 nodes. To check this, we can do a kubectl get nodes. Now we have our 5 nodes and you can see they all have a new name. But in this case, it's easier with VMS 1, 2, 3, 4, 5. Then we're going to create a new namespace as always. And we're going to deploy our application into this new namespace. While these pods are being created, now let's take a look at the YAML file. And what we can see here is I want to have 10 replicas. If we scroll further down, we can configure here the topology spread constraint. So with the max Q value of 2, we can tell Kubernetes that we want to have a maximum of 2 pods running on a node. We can configure the node with the topology key and we set it to host name. We could also set it to availability zone region. There's a whole bunch of options, but to keep it simple for now, let's just use nodes. Then in the next setting, when unsatisfiable, you can configure what to do. By default, it uses do not schedule. This means if it can't satisfy this rule, for example, if I want to have 10 replicas, but I only have 4 nodes and I want to have a maximum of 2 pods per node, then each node gets 2 pods and the remaining 2 won't be scheduled. But if you schedule anyway, then it will schedule them anyways. So in this case, if I have 10 pods and 4 nodes, I will have probably 2 nodes with 2 pods and 2 nodes with 3 pods. And therefore I have my 10. Lastly, you select the label so Kubernetes knows which pod you're talking about. If we now switch back to our terminal and then we do a kubectl get pods. But in this case, I sort by the node name just to make it easier to read to see which pod is running where. And let's make this a little bit smaller. So I hope you can still read this. But here we have number 1, number 2, number 3, number 4, and number 5. And as you can see, each node has 2 pods. This means we spread them evenly. What we now can do is we can also delete the deployment and then increase the replica count and see what happens. Let's do a cleanup of this window first. Then we do a kubectl delete deployment. Then we're going to update our replicas. So in this case, let's make it 15. But if we scroll down, we just leave the max Q as it is. And we also leave the schedule anyway as it is. Now let's save this file and then apply it. Now I can check our pods again with the nodes. So if we scroll out a little bit more, there you can see our nodes and we can see we have 3 running on the first one, on the second one, on the third one, and also on the fourth one, and also on the fifth one. In this case, we configured that we want to have 2 running, but since we deployed so many, it still scheduled them anyways, and it also spread them evenly. If you don't want to use this built-in feature, there are also open source tools that reschedule your pods. For example, they check where your pods are running and then rebalance your cluster. This means they delete some pods on one node and recreate them on another node. But I think to get started with this and for simple application, this is good enough. This is everything I wanted to show you today. So we've seen several options how we can schedule our pods. This means we can select on what node we want to run it. We can also select to not run it on nodes where we have other applications. For example, if you use special hardware like a GPU, I don't want to run it on a node with an application that's already using the GPU. The same with a database. In the end, we have seen how we can spread our pods over our nodes to make sure our applications are highly available. I said in the beginning, this is only an introduction on all the options we have. So if you're interested, go and take a look at all the options we have to configure it. It's way too many to look at all of them, but I hope it was useful, and I also hope to see you next week with another video.